Let's take a look at this equation here. And what we're going to do is have a look and see where this is a maximum and or a minimum point. So let's take a look and see how this would play out. Now, in actual fact, this is a nice, easy equation to draw. In fact, we can actually draw it, but right now we're just going to be concerned with where the points actually fall. So first of all, let's see where the turning points of this equation are. And to find the turning points, I'm just going to differentiate it. So dy dx is equal to 6x squared minus 6. So if we then go ahead and we factorize this, we're going to get a 6, we're going to get an x, what's that? X squared, yeah, let's get x squared minus 1. That would be fine. All right. Oh, is that a focus? Don't come back in focus. Ah, good. Now, if we go ahead now, we can actually factorize this further. We can actually say this is going to be 6. This is x plus 1, x minus 1. And if we make this whole thing equal to 0, and we want to make it equal to 0, because this is the gradient function, and with the gradient 0, there'll be a turning point or multiple turning points. In this case, there's going to be 2. So I'm going to divide everything first of all by 6. I don't want a 6 there. It's a bit of a pain. So I'm going to get 0 is equal to, I've got x plus 1 and x minus 1. So now the turning points are going to be either x is equal to negative 1 or x is equal to 1. So if we were to go ahead and kind of draw where this kind of works its way out, what we are finding is we've got a turning point at negative 1. There it is. And we've got a turning point at 1, in fact. There's our turning point at 1. Now this is a positive cubic. Yes, it hasn't got a negative in front, it's a positive cubic. So it must be in this kind of shape here, yeah? So if I was to draw this more or less, it's going to look something like this. It's going to go up there. That's going to be a maximum point, and it's going to cruise back down here. And this down here is going to be my minimum point. It's going to look something like this. This is going to be the maximum, and this is going to be the minimum. Oops, can't see that. This is going to be the minimum point. Now, we need to be able to prove, though, which of these particular points here is a maximum minimum. Now, we can see what it is if we can draw the graph. But we also we can't draw the graph. How do we show which is a maximum and which is a minimum? Well, we take a second differential. So we've differentiated once, we get 6x squared minus 6. So I've got dy dx, here it is, dy dx is equal to 6x squared minus 6. If we differentiate again, we go d squared y over dx squared. We're going to end up with 12x. There it is. Now, in the past example we used, we just looked at this value here and we said, is it positive or negative? But this is neither positive nor negative because it's not a value, it's just it's an expression, 12x. So what we do is we're going to put the values here and substitute those values into here to find out which one is maximum, which one is minimum. And again, the same rules apply. If the value this yields as a result of putting either one of these into here is going to be a greater than 0 value, then it's going to be a negative. And if the value is going to be less than 0, then it's going to be so the value is going to be less than 0. Which way did I say that? Okay, the value is going to be greater than 0, yeah? So if you get like a 2 or 3 or 10 or whatever else, a greater than 0 means it's a minimum. And if it's less than 0, it means it's a maximum. So let's see what that would be. So let's substitute this value in here first, yeah? So if I've got 12 times negative 1, that equals negative 12. A negative value, so I put this is a maximum because value is going to be less than 0. Yeah? And let's try putting the other value in now. Let's go put this value over here. Let's substitute this value in here. So now I'm going to have 12 times, not negative 1, but 12 times 1 is 12. Then this must be a minimum value. It's minimum because the value is greater than 0. So that's how we tell. In this case, this is a maximum value, and you can see it's a maximum. It rises to the maximum point. And this one, of course, is the minimum value because it heads down to the lowest possible point. I didn't draw that very well either, did I? Okay, hopefully that makes sense.